Hello and welcome to this webinar on Microk8s. Thanks for watching. My name is Calvin Hartwell. Today I'm going to be showing you how to deploy, configure, install Microk8s on your local workstation for working with containers and Kubernetes in a local development environment. Later on I'm going to be showing you how to utilize Microk8s as part of a CI/CD pipeline for Kubernetes integration testing. To get started with these instructions, I'm running on an Ubuntu 18.04 machine. We do provide instructions for installing and configuring Microk8s on Windows and OS X as well. However, this is outside the scope of this tutorial and that will be covered in some separate videos. The first thing I'm going to do is install the snap package for Microk8s. So if you're not familiar with snaps, they're essentially a new form of operating system package similar to a deb or RPM. However, they do utilize container technologies to make them ephemeral from the underlying operating system, so they can be installed on a variety of different platforms and releases of Ubuntu and other operating systems as well. They also have the ability to be automatically upgraded for minor releases, which is also quite useful for security flaws or bugs, etc. So with Microk8s installed, I can then do a Microk8s.inspect. So the Microk8s.inspect command will show me which of the services have been configured and are running as part of the cluster. This is quite useful for troubleshooting if something has died, or if you want to ensure that the Microk8s service has stopped. If you're running this on your laptop or in an environment with limited resources, if you're not using Kubernetes, it is useful to turn off the Microk8s daemon. In order to turn off Microk8s, you can run the Microk8s.stop command, and this will stop all of the daemon services, and you can then again check that they're stopped. There's another command as well called the status. If I run that now, it should tell us that Microk8s isn't running at all. But by default, when you install it, it will be running. Now, one thing I should note is that if you're totally doing this on a fresh machine, you may see a warning when you try to interact with Microk8s, and it will give you two commands that you need to run. One of those commands is usually a user mod, so that will be something like this. And essentially what this command is telling you to do is to add your user to the Microk8s group so you can interact with the Microk8s service. I've already run this command, so I don't need to do it again, but as soon as you've run that command, either restart your terminal, and basically, you'll inherit the new permissions that way, or you can just run the bash command, and that way, essentially, you'll basically get the new permissions that you've just requested. So, with Microk8s, I'm just going to start it, because I already turned it off. But when I tab Microk8s, you'll see there that there's a bunch of commands pre-built into the solution, which is really useful. So one of them is the kubectl command line tool. Kubectl is the Kubernetes command line tool for interacting with the Kubernetes API provided by Kubernetes clusters. And if you're familiar with Kubernetes, you most likely already used this before. But I can run the cluster info command, and it's all totally built in, and it just works out the box. I don't need to actually specify the config file or anything, it's already there and waiting to go. I can also do things like get PO, which means it's shorthand for pod. A pod in Kubernetes is one or more containers essentially, and you can see here that nothing's running on the cluster. So what I'm going to do is I'm going to enable some built-in workloads. One of them is the dashboard, DNS, ingress, and their registry. There are some other pre-built workloads, like for example Istio, which is a service mesh. If you wanted to play around with that, it's quite useful just being able to deploy and configure and enable it in a single command, rather than having to mess around with Helm or anything like that. So eventually all of this stuff will be spun up. I can then check that using Microk8s. You'll see that it's creating a bunch of containers, it's pulling the images in, and they're being created. Now, while I'm waiting for that, what I'm going to do is I'm going to open up another window, and I'm going to install a series of other software that I'm going to use later on throughout these videos. So one of those packages is kubectl. I'll be using this later on with my CI/CD pipeline section. I've already got the tool installed, but that's the command to install it on Ubuntu. The next command is Helm. So I've used Helm later on, but you can install the Helm client again using the snap. I've already got it installed, so I'm not going to bother. And then the last thing I'm going to need is actually not a snap, but a deb package, which is the Docker client. So I'm going to install Docker as well, and this is going to be used so I can build a container and then push it to a registry, and then I'm going to run that on top of K8s later on. So I've already got all of this software installed and configured already, so I'm not going to do it again, but if you want to follow along and run everything in this example, these are the tools you need to install. So if I just go back again and check, yeah, you'll see there that almost everything's complete and deployed apart from the registry, which is good for now. So what I'm going to do next is I'm going to access the dashboard. So Kubernetes does have a built-in dashboard, and Microk8s has this built-in as well once you've enabled it, like I've just done. To access that dashboard, I need to run the kubectl proxy command first. So on the bottom console there, I'm just going to run proxy. And what this does is essentially allows your local machine to interact with the Kubernetes API on localhost, basically. So what I'm going to do is essentially hit the dashboard now in my browser. And you'll see here that I'm given a login prompt. So I'm going to log in with a token. So in order to get that token, I'm going to use kubectl get so I run the command get all secrets, and you'll see here there's a big list, and the one that I want is the default token. So I'm going to use the command Microk8s kubectl get secret, no, describe secret, and the namespace is kubectl. So if you're not familiar with Kubernetes, a namespace is essentially a virtual cluster. So they provide a way of cutting and carving a cluster, one big cluster, Kubernetes cluster, up into multiple clusters. And they're useful obviously for security purposes, but also can be used for restricting resources to certain things and many other things in the cluster. But you can see here that there's several namespaces have been created. One is called kubesystem, which is the one which most of the actual core Kubernetes services run in. There's some others there for the ingress controllers and the registry, etc. So I've copied this token. I've used the describe command, and the describe command can be used to view a Kubernetes construct in more detail. So I've just found this token which has already been pre-generated, and now I'm going to log into the dashboard. And so in the dashboard you can see basically all the different constructs that have been deployed or haven't been deployed. So there's no cron jobs, for example, running on the cluster right now. But you can see some of the cluster roles and the information about the node. So this is Calvin H workstation, which is my local machine. And you can see some stuff there around the memory limits that it's set and the core limits and stuff that it's set. You also have a list here of the namespaces, as I was just talking about. And that's basically it. That's essentially a very quick introduction to installing and configuring Microk8s. If I want to enable some other pre-built workloads, for example Istio, just go back and type, just enable actually. It will essentially go through and enable Istio for me quite easily. Now, as part of the example that I'm going to do later, I'm going to build a container and I'm going to push that to a registry. And I've actually set up GitLab Community Edition running on Kubernetes, which is actually running Charm Kubernetes, which is Canonical's distribution. And essentially what I'm going to do is push and create a project there, and there's some automation that whenever I push a change to that registry, it will rebuild the container and deploy it, test it, and then push it to production if everything's green. But in order for me to do that, what I'm going to do first is just show you a quick example of a simple container and how that's built and how that's deployed on K8s. So inside of this repo, and the repository and the instruction around everything will be provided after the session. It will all be publicly accessible. But inside of here, I have a container. Or at least the source code for a container. So there's a file in here called the Docker file. Now this is a very, very simple container. Basically, you can see there that it's pulling, in the first line of the Docker file, it says from Ubuntu. And what this will do is it will pull the Ubuntu base image, and then everything that I'm layering in here will go on top of that base image. And these are the official Ubuntu base images pushed to Docker Hub, effectively by Canonical. So the next section just sets the maintainer name, which is myself. It's usually a good thing to set that, so whoever's reading this can find out who's written the code. The install section, the run section, will just run some basic commands. So here I'm just running apt get update, so I get the latest packages. Then I'm installing nginx, and then I'm basically configuring nginx to be run in a simple way. And nginx, if you're not familiar with it, is just a web server. So this simple example here is just going to literally display a static web page with a picture on it, and there's not really much going on here. One of the things it does do though is inject the host name from the underlying machine that it's running on, which is quite interesting, especially if you've got a cluster with multiple nodes in it, because if you scale up or scale down a workload, you can see where it's running. And you can see here that I'm also exposing ports 80 and 443, and I'm also just setting it to run nginx. This is basically the command that it's going to run when the container fires, and this is very simple, hopefully quite straightforward. If you look at the official nginx container that's provided by F5 directly, you'll see on the GitLab, on the GitHub repo, something very similar to this. So you can also see in here that I have some other things which aren't related to Docker so much. One is called the tests.cdk-cats-tests.sh, which is basically a bash script for testing and we use this later on as part of that CI/CD pipeline that I mentioned. And there's also a manifest.yaml file. Now the manifest.yaml file describes using Kubernetes constructs how to deploy this container on top of K8s. So we have what's called a deployment here, and if you're already familiar with Kubernetes, I'm sure you already know what this is, but if you don't, a deployment is a layer above pods, and it's essentially an improved way of describing how pods should be deployed and monitored. So just some things to note in here. The label I've given it is called cdk-cats, and this is used later on to work out if the container is running on the cluster. Replica count, this is essentially how many times I want this container to run on the cluster. You can, after you've deployed the container, you can also edit this up and down to see the effects of it being scaled, basically. But by default, it's going to run 5 copies if I run this. Now the important stuff here is that it's pulling from a private registry called registry.calvinh.com, which is something I've set up using GitLab. My user on GitLab here is Calvin H. The project in GitLab that I've created is called Microk8s Webinar. The container name, once I pushed it to the Docker registry, the private Docker registry in this case, the container name is cdk-cats, and then I've tagged it with latest. And usually you would use these tags to control the version, and every time you push a new one, you can use this to increase the value as part of your pipeline. I've got a simple liveness probe here on port 80. It doesn't, there's no complexity going on here really. It's just using a simple HTTP workload, so there's nothing really exciting here. So I'm also creating a service which will deploy a node port and port 380, so 30,080 in this case. And typically within a K8s cluster, there's a port range that's open between, I think it's 30,080 and 36 or 37,000, and this is configurable usually as part of the Kubernetes master services. But this is just the default range. You can find out more about this in the Kubernetes manual. But you can see here that I've opened this port up and the target port is port 80 because that's the port that I'm basically exposing as part of the workload. And it is a simple web application, so I'd expect it either to be 80 or 443. And finally down here I have an ingress rule. Now this is not going to be used as part of the local testing, but when I push this to production I will be using this later on. And essentially an ingress rule is a way of doing layer 7 load balancing, and what we mean by that is essentially the cluster will resolve a DNS entry to a collection of pods in the background. So if I have my DNS set up correctly, in this case I do, on my production cluster I have a series of A records and some other DNS records pointing to my Kubernetes worker node, which will resolve essentially anything that has the calvin.h.com DNS entry. So we're not going to make use of this, but we are going to basically build this container. We're going to push this container to the registry, and then we're going to deploy it on our Microk8s cluster locally. So if you can imagine, your developers or yourself as a developer, basically new to containers, I've already logged into my registry, but with Docker configured, what I'm going to do is a sudo docker build. And what this is going to do is build my container. So it's very quick, it's a very simple container, has very few layers. Docker is a layered technology. It builds from a series of containers, and the cool thing is you can actually swap those layers out with new versions, and they're usually quite ephemeral in the way it's designed. So if you do have a new release of one of the containers in the middle, you can swap that out and still everything should work fine. So with the container built, what I'm actually going to do now is I'm going to tag it, and I'm then going to push it to my registry for later on. So so I built the container. Let's just tag it with the registry. Just check I've typed that correctly. I see some small typos. Yeah, looks good. Okay, so I've tagged it, and I've already logged into my private registry using the Docker daemon. So to do that, you do a command like this, and then it would be your registry, sorry, your username, your password, and then your registry endpoint, which in my case is calvin.h.com. So that's how I've pushed. I've logged in through the Docker daemon to my registry, so that means I can push containers to it. And then finally, I'll do the command docker push. Check for some more typos. I've made a typo here. Yeah, it looks fine. Oh, there we go. And there we go. It's essentially pushing the layers, and it should be available on the registry soon. So that's essentially how you build a container, and there are some much more complex examples out there. That's really outside the scope of this tutorial. My idea was just to show you how to build a very simple container. A static website is usually fine for testing. I've been using this container for testing for many years, and it's just a very nice simple example for people that are new to K8s or building OCI containers. So once this is pushed, what I'm going to do then is I'm going to deploy this container onto my Microk8s cluster. There we go. So it's pushed to the registry. So in order to do this, I'm just going to run apply-f against the manifest. And you'll see there that it's created the deployment, it's created the service, and it's created the ingress rule. So now if I do microk8s.kubectl get pods, you should see the cats. So you can see here that it's trying to create them. and we can see now that it has pulled them and it's running them. And you can see that there. Right. So the next thing I'm going to do is get service. And you can see here that it's created the no port, and I have a cluster IP available. I'm just going to go in my browser, I'm going to hit that. And you can see here, straight away, here is the simple container, and there's the container host name, and yeah, that's basically it. That's a very simple container, end-to-end deployment, build and deployment on my local machine. So you can imagine that, you know, as a developer, you can set up a very simple pipeline running locally, and you can work in this way. However, if you want something more automated, that's what we're going to cover next as part of an automated pipeline using GitLab. Some more Microk8 stuff that I wanted to cover, and this is all in the manual, but it does have some really nice functionality around clustering. So if you're running, say, several machines and you want to give yourself a very quick and easy Kubernetes cluster using a series of hosts, you can use the Microk8s clustering functionality. And this is done using the command, just make the font a little bit bigger. This is done using the command microk8s.add node. And essentially what this will do is generate a series of commands for you to use, particularly the join command. And you can use this to essentially, you know, create a cluster. So if you run this command for each of the different machines you want in the cluster, you install Microk8s on each one, with obviously with Ubuntu or whichever operating system you're using, and then if you just run this join command on all the other nodes, they will come up as a single cluster. And then eventually what you'll see is if you do get nodes, you'll see a series of worker nodes available in here. This is really useful if you want like a quick, a small cluster if you're testing at home, for example, doing local development, or if you're looking at something that's a bit lightweight for the edge or for some kind of IoT use case. This solution is really easy to get started with, really easy to set up, really easy to upgrade and manage over time. There's a blog post on our website here which describes how to utilize such a solution for essentially, you know, using some ARM machines, using some Raspberry Pis as a really simple, cheap entry to a Kubernetes cluster at home. So yeah, that's basically Microk8s in a nutshell for a local developer. I'm going to later on go into how to use this as part of a CI/CD pipeline, so I'll be back shortly.